Dear learners, in this session, we will have a brief introduction about forces. And this is the introduction about forces. And the action of forces is only two types. One is it pushes the material or it pulls the material. According to the engineering mechanics, the body is considered to be a rigid body. Rigid body is a body that doesn't deforms. So, when a force acts on a rigid body, either it pushes the body or pulls the body. And according to statics, the engineering mechanics is briefly classified as statics and dynamics. For statics, if the body is at rest, then the forces is acting on the body when it is at rest, then the study is called as statics. And coming for dynamics, when the body is in movement, the forces acting on the body when it is in movement, then the reaction of the bodies to the action of the forces when it is moving, the study is called as dynamics. These are some of the fundamental quantities. One is mass, length, and time. And coming to this Newton's first law, to explain Newton's first law, look at this football in the ground. If no player is hitting the ball remains in its state of rest. So this is an example for Newton's first law. When no force is acting on a body, Newton's first law states that when no force is acting on a body, the body will remain in its state of rest. So if nothing is happening to the body will be in the state of rest. And Newton's first law. And the same example for Newton's second law. If a player is hitting the ball will make a movement. So Newton's second law states that if some force acts on a body, the body will tend to move. And this is Newton's third law. Everyone is familiar with this Newton's third law, and it is every action has its equal and opposite reaction. And force representation and characteristics. Force is represented by its magnitude. The length of the force explains the magnitude and its direction. The arrowhead represents the direction, and it will have a line of action, and it will have a sense either in the positive direction or in the negative direction, and it will have a point of application where the force is acting on a body. This is the coordinate system, and in this coordinate system there are three axes. One is called as x, y and z. And these are the force system according to the coordinate system. If a force is acting only in a plane, I mean in the x and y, and z is not considered, it is called as a plane. Then if the force is acting in a plane, then it is called as coplanar collinear forces. And if the forces is acting in a plane and all the forces are acting at only one point, then that is a concurrent point, and this force system is called as coplanar concurrent force system. And if the forces is acting in the same in the plane, and if it is acting parallel to each other, then the system is called as coplanar parallel forces. This is an example of coplanar parallel forces. And if you consider the space system, in this space system, it will have one x-axis, one y-axis, and z-axis. If forces is acting in a space apart from this plane, then it is called as non-coplanar. If the forces is acting at some other points and some other directions, then it is called as non-concurrent. Two force system. This is an example of a two force system: parallelogram law of forces and triangular law of forces. Number of forces more than two. This can be solved by a theory called as Polygon law of forces. Resolution of forces. For resolution of forces, if the forces is acting at a plane at a different angles, then it will be resolved into two components. One is called as the tangential component, another one is called as the sine component. One is cos component, another one is called as the sine component. So this positive negative sign will be taken in the x direction and y direction. Equilibrium. Equilibrium, if all the forces acting on the body is equal to 0, then it is called as equilibrium. Lami's theorem states that if three concurrent forces are acting, coplanar concurrent forces are acting at a point, then the force to the sine of the opposite to angle of the opposite two forces will be a constant. Position vector. This is called as position vector and it represents the position of a force. And this is principle of transmissibility. If the line of action is not changed, if the line of action is not changed, the forces acting at any point will be equal in a body, provided the line of action must not be must not be changed. This is moment. If some point is fixed and if a force is given at the opposite end, it will form a moment. And this is degrees of freedom. When you go for degrees of freedom, a free body in a space, I mean in a space coordinate system which is having x, y and z, this body will have six kind of movement. Three movement in the translation direction and three in the rotational direction. And these are some of the support reactions. One is fixed end support, where there are three forces will be acting, three reactions will be acting, horizontal, vertical and a moment. In a pin support, two reactions will be acting, horizontal and vertical. In a roller support, only one reaction will be acting, that is vertical. And this is couple. If two forces acts at a distance in the opposite direction, then it will form a couple. And this is the center of gravity where the lumped mass is considered to be acting on one point. And the centroid is considered for plane sections. It is for area, not for the volume. If volume is considered, then it is called a center of gravity. If only plane is considered, then it is called a centroid. Inertia, and this is moment of inertia. If it is acting at an axis of rotation, then it is called as moment of inertia. I hope everyone understood the video. Thanks for watching.